Hey folks, so in this video, I'm going to elaborate on the DFS algorithm that we just talked about. So this is kind of going to be maybe almost the main part of the algorithm because the code was so clean. So let's say we have this graph here and we want to explore it. And I have this little prompt here, maybe it looks like an exercise you'll see at some point. And so what I want to do here is what it says, right? Run the DFS algorithm on the graph to find the paths from node 0. All right, so let's just try envisioning this. So initially I start by running DFS of 0. DFS of 0, I am going to basically have to have that marked because it's like, well, that's my starting place, so it's got to be marked, okay? So stuff is good. Then remember that in DFS, I basically go and look at all the neighbors and see, are they marked? If they're not, then run DFS. So I can do that, right? I can look at my diagram here and I can say, you know what? I'm starting here, I'm kind of branching out, right? I'm going over there. I basically only have one neighbor here. I only have a neighbor of 1, so I don't really have much choice. So I can go ahead and do this. Now, I'm going to draw this in a certain way. I'm going to draw it with an indent. So what that represents is that the call to DFS of 0 called DFS of 1, right? This is very important for us. So I'm at 1, right? And really I should mark that right as I go to it. So that's good to go. And now I have choices here, right? I have 2, 3, and 4, right? All my different choices of places I could go. So in DFS, right, I need to basically pick who to visit next, right? There is some loop, right, that basically is going to go and it's going to look at all these different nodes that are adjacent to it, right? And so I have actually, there's a rule here, basically says when we look at edges, assume they're discovered in the order of the node labels. So here, if I'm imagining that I'm at 1, I'm doing DFS of 1, I'm looking at its neighbors, I'm going to look at 0, 2, 3, and then 4, right? So that ordering. So yeah, just imagine you're in the code here. Code is running, looks at 0, 0 is marked, it skips it, okay? Nothing to do there. Then it looks at 2, hey, it's not marked, I can go and go there. So I'll do DFS of 2. And really what I should be doing here, I don't really want to clutter up my diagrams too much, but it would be good for me to have the following. I would write something maybe like this. Marked of 2 equal true. Something like that, right? To indicate that I'm marking a node as I get into it. Right, and if I were to do that, I would have also a marked, over here. This should be marked of 0, marked of 1, right? If I had more space, I would blow that up, but I don't. So now, right, I've kind of went to 1. Now I go over to 2. Right, so I went from 0 to 1, then from 1 I go to 2. I'm at 2. 2 doesn't have anything next to it, so it doesn't need to make any recursive calls. I'm done. Okay. So what happens is, right, when I'm done, right, I'm done. I basically return from that function and go back to my caller because this is a recursive algorithm, right? So when the inner call finishes, I jump back out to the call that's right outside of it. In this case, that's DFS of 1. So I'm back to DFS of 1. DFS of 1 actually is in the middle of a loop, right? So DFS of 1 was looping along its neighbors, and it just so happened that when I got to 2, it was like, oh, it's unmarked, I need to call myself, so it kind of got distracted and then made another call. But now that I'm back, I've basically stepped back to 1, I need to finish that loop, right? So I need to finish doing whatever 1 wanted to do. So in this case, 1 is done looking at 0 and 2 as its neighbors. Now it looks at 3 as its neighbor. So it looks at 3 as its neighbor, and it sees it's unmarked, so it goes to try and explore it. So it does a DFS of 3, right? So somehow my notation here is indicating that the call of DFS of 1 made 2 calls, right? I made a call to DFS of 2, and I made a call DFS of 3, right? That's what DFS of 1 did. And then inside DFS of 1, that's where I do my mark on 3 equal true. So then I'm good to go there. So that's true. Let's see. And this should be marked over here as well. This should be marked over here as well. So now I'm looking at 3, right? So it's like, well, now I'm over here. I'm at 3. What do I do when I'm at 3? I'm looking at the neighbors. Neighbors are 1 and 4. Well, 1's already marked. Skip it. Look at 4. Oh, hey, that thing isn't marked. So let me go explore it. So DFS of 3 will actually call DFS of 4, which will then mark the 4th one. All right, so then I go over here, and this is marked, right? So all of a sudden, right, I'm done, right? 4 only has 1 as a neighbor, but 1 is already marked, so it can't do anything. So basically, it backs up to 3. 3, it's seen all its neighbors, so it's done. Then it goes back to 1. But then at 1, right, 1, this call over here, right, this one over here, we're there. And basically, it's like 1 is still looping over its list of neighbors, and the only thing left on the list is a 4, but oh, hey, that's already marked, right? I got marked actually by that call to 3 that DFS of 1 itself did make, right? So DFS of 1 doesn't have anything else to do with its neighbors, so it's done. So then it finishes, right? And it goes back to DFS of 0. DFS of 0 is seeing all its neighbors, so then it returns and exits out. Okay, so then we finish exploring my graph. So yeah, this is what I get, right? So this is my trace of DFS calls and marking calls, right, to show how I got from one place to another and what is the route that I took, right? And you can see up top that I was basically maintaining my graph with my little marks, and then also just for understanding about the arrows so that I could see how I got from one node to another node. All right, so that's all I got for this algorithm trace. Hopefully that made sense. You guys will be working this on an exercise, if not a homework. So make sure this makes sense. All right, so in the next video, we're going to spend a little bit more time looking at the overall algorithm and then actually a visualization as well. I want to make sure you guys have a really good sense of how this algorithm works. So I'll see you in those videos.